Hi there. Welcome again to our review of the topic discussed. So here in this animation, you see that the dog is enjoying its ride in a merry-go-round. So how are we going to relate the three laws of motion to an object that moves or that travels in a circular path? I have here two questions that somehow will help us to understand that there are some forces available or at the center of the circle that holds up an object that travels in a circular path. First question is that how does gravity make satellites revolve at a constant speed? How does it happen? And then the second question is that what will happen if all of a sudden the Earth loses its gravitational pull on the satellite? Obviously, if there is no gravity, you know what will happen to the satellite? It will move away from the Earth since there is no gravity that will hold it. So today, we need to infer that circular motion requires the application of constant force directed toward the center of the circle. So like what I told you, that in the circular motion, there is a requirement of this application of this constant force because it's directed toward the center of the circle. And we also need to consider the acceleration of that object traveling in a circular motion. So we call it that force. It is directed at the middle or at the center of the circle. Is the centripetal force. So therefore, according to Newton's second law, it is said there that acceleration is produced by a net force. If there is no net force, then there will be no acceleration. The net force and the acceleration must be in the same direction. So if you're going to apply some force to the object, this object's acceleration should follow the direction of the net force. If we're going to apply that in a uniform circular motion, the acceleration becomes the centripetal acceleration. Sounds familiar, right? And the net force. Since it is also directed toward the axis of rotation, here at the middle, it also becomes the centripetal force. So then again, that kind of force that holds this object travel in a circular path was been held by this force called centripetal force. The location of this is at the center of the circle. Like in this animation, the girl with the purple hair serves as a centripetal force, and it has a force that holds the object traveling in a circular path. If there will be no force, then this little baby traveling in a circular path will no longer travel on that path. So the net force on an object, how are we going to define centripetal force? It is the net force on an object that maintains the object's circular path. Again, it's the net force. To be able to maintain this object traveling in a circular path, and it is always directed toward the center of the circular path. So to find the centripetal force of the object, it is equals to, you have to multiply the mass of the object multiplied to the acceleration or the centripetal acceleration. Same like the formula to get the force in the law of acceleration. Its relationship or acceleration's relationship with the force and with the mass. So in centripetal force, I have here some examples that shows you how these forces are being pulled at the center or directed toward the center of the circle as this object or the car is traveling a circular path. Those forces here are the centripetal force. Another example of animation showing the centripetal force. And to maintain this kind or state of motion, the guy should maintain the acceleration of the motorcycle to be able to ride on the wall without falling. There's another application of the centripetal force showing you how the car traveled in a circular path without even falling as it reaches the top of the coaster. The spinning wheel or the spinning swing, and another toy showing centripetal force in it. So if the forces are not directed toward the center of the circle, it is not centrifugal anymore, but rather it's not centripetal anymore, but rather it's centrifugal force. Like this one, if there's no longer centripetal force, then it may just place this object traveling in a circular path away from the circle. Another example of centrifugal. And whenever this gymnast jumps out of this circular path, that will be considered as centrifugal force. So how are we going to differentiate now centrifugal force from centripetal? Remember that the forces, if that is directed toward the center of the circle, then that is centripetal force. If not, if that is away from the center, then that is centrifugal force. So I hope you learned something about the centripetal force, and good luck on the next review. Bye-bye.